We're going to start talking about the chain rule, and the chain rule is the last derivative rule you need that will allow you to take the derivative of any explicit single variable function. So basically any function that is in the form y equals or f of x equals. Once you know the chain rule, you will be able to take any derivative of that form. These functions right here, over on the left, we don't need a chain rule for. So technically speaking, you should be able to take the derivative of these functions right now. So let's look over at the right-hand column, and I've written variations of these functions, and you can look at some of the things that affect the chain rule, so you can kind of start processing it before you even know what it is. This is just x squared plus 1. This one is the square root of x squared plus 1. So we call that a composite function. Like we've found the derivative of just the square root of x, and we found the derivative of x squared plus 1. We have not yet found the derivative of the square root of a binomial, or anything other than x. The chain rule is what allows you to do that. We have found the derivative of all 6 trig functions as long as they are to the first power and the angle is just plain x or plain theta. We have not yet taken the derivative of trig functions where the angle is something other than plain x or plain theta. Up until now, we have not taken the derivative of anything that has a parentheses to a power unless we distribute it out first. But at this point, we're not going to want to multiply this out 5 times. That would take a long time. The chain rule will allow us to take this derivative without distributing it out. Chain rule will also allow us to take the derivative of trig functions to a power. And once again, here's another one that's to a big power. And the key to understanding most of the chain rule is this. If you look at something and you write it as parentheses to a power, you have to address the derivative of the inside as well as the power. So that's what the chain rule is kind of in a nutshell. It's how we take the derivative of what we call composite functions. So here's what the chain rule says. It says if we take the derivative with respect to x of a composite function in the form f of g of x, that it will always equal the derivative of the outside function multiplied by the derivative of the inside function. That's basically what it says. So basically you have to take the derivative twice. Take the derivative of the overall outside function, and then you multiply it by the derivative of the inside function. This means that if we take the derivative of composite functions, in other words, functions that are inside a grouping symbol, whether that symbol is parentheses to a power or it's a radical, and the inner derivative is not 1, we must multiply the power rule or original derivative by the derivative of the inside function. Until you see a few of these, that's probably still not going to make sense. The chain rule, though, is what allows us to utilize the general power rule. And we don't ever usually talk about this by name, but what we say is if we have anything to a power, regardless of what's inside that parenthesis or grouping symbol, we can find the derivative by doing power times coefficient down 1 to the power of the entire parentheses and multiplying by the derivative of the inside of the parentheses. So you no longer, in other words, you no longer have to get rid of parentheses. If you have parentheses to a power, you can keep them now, and just remember that after you do the power rule, you multiply by the derivative of the inside of the parentheses. So for our first example, we want to look at f of x equals 3 minus 2x squared quantity cubed. So we have a binomial inside of a parenthesis to a power on the outside. In order to work on this, all we do is we take the outside power times the coefficient of the entire parenthesis, which in this case is a 1, and we say 3 times 1, subtract 1 from the entire power, and then you multiply everything by the derivative of the inside of that parenthesis. So what is the derivative of 3 minus 2x squared? Negative 4x. We multiply everybody through by negative 4x. And you can set in parentheses or you can just tack it on with a little dot. The calculus is done. It really is just a single step. Power times coefficient, down 1 on the power, times the derivative of the inside. So anytime you're doing the power rule to a binomial or greater, you now have to remember to multiply by the derivative of the inside as well. Then you clean it up and bring your monomials to the front. So that 3 and negative 4 make negative 12. Bring the x to the front and leave your binomial at the end. That is already in factored form, if you'll notice, because there is no addition or subtraction outside of the parentheses. For the second example, we have that g of x is equal to the cube root of the quantity x squared minus 1 squared. So we have the cube root of a binomial squared. We first need to look at that as a parentheses to a power. Because it's the cube root, we need to rewrite this algebraically in exponential form. So we have our radicand, which is x squared minus 1 squared. And the cube root of that means that really it's to the 1/3 power, right? But because it's already squared, instead of the 1/3 power, it's going to be to the 2/3 power. And once we see it as a parentheses to the power, most people do okay with it. So we'll have g prime of x is equal to power times coefficient, down 1 on the power, times the derivative of the inside, which is 2x. So that is the only calculus step in the entire thing. All your calculus is done. Now we just have to figure out a way to clean that up and rewrite it in radical form. Everything is multiplied. There is no addition or subtraction. So what we need to do is go through and collect everything that belongs on top and everything that belongs on bottom. So the 2 and the 2x will make 4x on top. And on bottom, we already have a 3, and this guy is going to drop down to join him to make his power positive. So if I drop that into the denominator, it will become x squared minus 1 to the positive 1/3, also known as the cube root of x squared minus 1. That is a single term. We don't need a common denominator. We already have one. And we can't really factor anything, so we're finished. For our third example, we have y equals the quantity 3 minus x raised to the 4th power. We already have it as a parentheses to a power, so we're just going to apply the chain rule. So we'll do the general power rule and say that the derivative is equal to power times coefficient, down 1 on the power, but the chain rule necessitates that we multiply all of that by the derivative of the inside. What is the derivative of the inside? Negative 1, yeah. So we're going to multiply by negative 1, and then we'll just clean it up. On the outside of the parentheses, we have a 4 and a negative 1. We multiply those together and get a negative 4, 3 minus x, quantity cubed. So that's probably the easiest one. Do you guys have any questions so far? I want you to kind of put a big star by this one. A lot of people try to do the quotient rule with this fourth example, but because the numerator is a constant, I'm going to recommend that we don't. You can do the quotient rule, you would get the same answer, but it would just take you a little longer. If you have a constant on top or bottom, there's almost always an alternative. And if the constant is on top, we can simply relocate the denominator, bring it up to the top by making its exponent negative. So I can have the negative 7 parentheses 2t minus 3 to the negative 2 power. And if you look at it like that, as negative 7 times a binomial to a negative power, you can just apply the chain rule and the power rule. And we can take the derivative and say power times coefficient is negative 2 times negative 7, which is positive 14. Subtract 1 from the power of the binomial, which would make it to the negative 3. Negative 2 minus 1 is negative 3. But you have to remember to multiply everything through by the derivative of the inside, which in this case is just 2. Then you just come through and you clean it up. You have 14 times 2 is 28, and the negative 3 power drops that parentheses back to the denominator. So that's pretty much the chain rule for binomials and greater.